Good morning. Let's start with a new chapter today, that is chapter 12, Exponents and Powers. So, let's start with the introduction. The exponents tells us that how many times the number should be multiplied. It is called the exponential form. So, first of all, why we are studying this chapter? We have been going through a lot of numbers. Like if there are some large numbers like diameter of earth, diameter of sun, so how we will represent it? We can't keep on writing the zeros here. So for that easiness, we are using we are writing it in a exponent form. So what is exponent? It tells us that how many times a particular number is to be multiplied. Like here I have taken as an example 10 raised to 9. This is an exponential form where 9 is the exponent, which tells us this 10, the digit 10 is to be multiplied 9 times with itself. Like here I have done here 10 is the base, so this will be considered as base, and 9 is the exponent, or you can say as power or the degree. So here 10 is the base and 9 is the exponent, and complete number is the power. So this whole number we can say as power. Now 10 will be multiplied 9 times, like 10 multiplied by 10 multiplied by 10, this 9 times I am multiplying. So basically exponent is this 9 and this is the base, where base is to be multiplied number of times is this exponent. Now next topic is powers with negative exponents. So there will be positive exponent and also negative exponents will be there. So how you will write the negative exponents, how we will simplify it? So the exponents could be negative also, and we can convert them in positive by the following method. How we will convert? Let's see. Suppose this is the base 100 raised to minus 3, where minus 3 is the negative exponent. So for converting a negative exponent into positive, we have to write the reciprocal of it, or we have to divide it. Like here is equal to 1 by 100 raised to 3. Then this negative exponent will convert into positive. We have done the reciprocal of it. So this shows that for any non-zero negative integers a, for any non-zero negative integers a, the format will be a raised to minus m. Wherever there is a negative exponent, it will be converted into positive by 1 by a raised to m. This is the standard form of converting negative exponent into positive. And other one is a raised to m is the multiplicative inverse of a raised to minus m. So this is also the multiplicative inverse of a raised to minus m. Now one example I am taking where we have to express 1425.36 in expanded form. So how you will do it? 1425.36 is equal to, first of all, 1 is in the thousand place, so I multiply with 1000. 4 is in the 100 place, so multiply with 100. 2 is in the 10th place, so multiply by 10, plus 5 it is in 1's place, so multiply by 1. Now whatever digits comes after points, let's do you know that how we are doing it, that is 3. It is 1/10 of the place, so 3 by 10th, plus now 6 is 1 by 100th place, so 6 by 100 we are doing. So this is in an expanded form. Now how to convert into the exponential form? So this is having 3 zeros, so 10 cube plus 4 multiplied by 10 square here, then 2 multiplied by 10 raised to 1 plus 5 multiplied by 10 raised to 0. For 1 we are writing as 10 raised to 0. This we will study later on the loss part of the exponents, plus 3 multiplied by this, it is in division, so it will come as minus 1, like I have already taught you in the negative exponent how we are converting it into positive. So if we are bringing it up, it will be minus 1 plus 6 multiplied by 10 raised to minus 2 for this. Okay, so whenever any expression is given which we have to write in expanded form, this way you have to write by writing multiplying it with the place values. Next topic we are studying is laws of exponents. So if we have a and b as base and m and n as exponents, then how we will represent it? Now first law is a raised to m multiplied by a raised to n. Whenever such sum is coming where the exponents are different like m and n and it is base should be same. So a and a is the same base and it is multiplied, then in such case the base will remain as it is, that is a, and their exponents will be added, that is m plus n. That is our first law of multiplication of the same base with different exponents. Let's take an example. I have taken here 7 raised to 3 multiplied by 7 raised to 4, where the base 7 is same and the exponents are different and the multiplication sign is there in between them. So according to our law, the exponents should be added. So here 7 raised to 3 plus 4, so is equal to 7 raised to 7. Now second law, a raised to m the whole raised to n. So that will be is equal to, if such sum is coming where a raised to m is there and the whole raised to n. So it is simply we have to multiply the exponents, that is m multiplied by n. The base will remain the same, that is a, m multiplied by n. So let's take an example for this law. 7 raised to 3 the whole raised to 4, that is equal to 7 raised to 3 multiplied by 4. Here we have to multiply the exponents, the 3 multiplied by 4, that is 12. So our answer is 7 raised to 12. Now third law of exponent is a raised to m divided by a raised to n. Whenever some this type of sum is coming where the base is same and the exponents are different and they are in division form, so what will be done? Their exponents will be subtracted, that is a raised to m minus n, where m should be always greater than n. So here I have taken an example, 7 raised to 4 divided by 7 raised to 3, that is equal to, according to the law, m minus n. So here this is m, so 4 minus 3, that is equal to 1. So is equal to 7 raised to 1, that is nothing but is equal to 7. Now fourth law is a raised to m b raised to m. Here see the base are different, that is a and b, two different base we have taken, but their exponents are same. So suppose such sum is coming where the base are different but the exponents are same, we can write it as ab the whole raised to m, because both have the same exponent. So example I have taken here, 7 cube this multiplied by 4 cube, that is equal to 7 multiplied by 4 the whole cube. Then you can multiply the base and then put the exponent in common. Okay, so this is our fourth law. Now fifth, a raised to 0, like in expanded form we have seen 10 raised to 0, then we have got it as we have represented 1 as 10 raised to 0. So here this is the law where any base is raised to 0, then the answer will be 1. Like example here, 7 raised to 0 is equal to 1. So this is our fifth law. Then sixth, a raised to 1 is always the same number, that is a raised to 1, it is multiplied just one time, so this is a. So example is 7 raised to 1 is equal to 7. Now seventh, 1 by a raised to n. So this is negative exponent, we have this is in positive form. So if we are bringing this up, then it will become negative. So a raised to minus n, that is in negative form. So 1 by 7 cube will be represented as 7 raised to minus cube. Let's take an example to simplify and write in exponential form. How we will write it? So here a question is this: 2 raised to 5 divided by 2 raised to 8 the whole raised to 5 multiplied by 2 raised to minus 5. So as per the rule of law of exponent, whenever there is a division, what will it happen? The exponents will get subtracted. 5 minus 8. Here base is same, so 2 will remain as it is. For division the rule is 5 minus 8. We have to subtract the exponents. So 5 minus 8 the whole raised to 5. So first we will simplify it, that is 5 minus 8 is 2 raised to minus 3. We have got a negative exponent. Now what is the another law we have studied? If it is power raised to power, so it will get multiplied. So minus 3 multiplied by 5. So here it will be multiplication. So minus 3 multiplied by 5 will be 2 raised to minus 15. Okay, so this we are bringing it as it is, multiply by 2 raised to minus 5. Now what is the another law that we have studied for multiplication? If the multiplication is there and both the base is same, so their exponents will be added. So here it would be minus 15 plus minus 5, which I have written as plus minus, you know that it is minus. So I have written it as minus 15 minus 5. So now minus 15 minus 5 is, we have to add it, and the greater number has negative sign, so minus 20. So we have got a base with negative exponent, and how to convert it into positive, that we are bringing it in, we have to do the reciprocal, that is 1 by 2 raised to 20. So this way we have to simplify if any sum is coming in exponent form by using all the laws of exponents.